All right, so today let's talk about the zeros, or the roots of a quadratic. So your zeros are going to be the location of your quadratic where it intercepts with the x-axis. So another way of saying that is the locations of your quadratic where y equals 0. Now we can see we've spent the last couple days working to put our equations of quadratics into what we call factored form. It looks something like this. Now in this form we can write it out as x minus s and x minus t, where s and t are the two values here and here. Oops. Are the two values of x where we could get y to equal 0. So you'll see what I mean in a moment. But you can see that because the operation that's happening here on the right-hand side of my equation is multiplication between my two brackets, if either one of these two brackets equaled 0, then the entire side of this equation will equal 0, meaning y itself will equal 0. So let's see. So if we take a look at this equation here, we can see that it is in factored form. That means I have x minus s, x minus t here, and I can pull out, okay, well, t equals -2. It's similar to when we were working in vertex form, when h was subtracted within the equation. So we switch its sign when we're pulling it out. So t equals -2 and s equals -6. We can see right away here if we were to set x in this equation here, I'm just going to move these over. If I were to set x equal to, if x equals, say, -6. So I'd have -6 plus 6 and -6 plus 2. I can see right away my first pair of brackets would equal 0, my second pair of brackets would equal -4. I'd multiply those two together and I would have 0, so y equals 0. I could see that as well if I substituted in x equals -2. Now let's just put these back here. So my two zeros here are, my two zeros are -6 and -2. So that's what I would write here. Zeros are -6 and -2. That's all the question's asking. The next one, I'm not going to spend as much time on it. The next one, I can pull s equals +2 this time because it's a negative within the brackets, and t equals +8. So my two zeros are 2 and 8. And for c here, I can pull out s equals -1 because it's a +1 in the brackets, and then t equals +3 because it's negative in the brackets. So we can see we can have a few different situations. Sometimes we'll see our zeros where both of them are negative, like for A. Sometimes we'll see our zeros where both are positive, like for B. And sometimes we'll see our zeros where one is positive, one is negative, just like for C here. Now let's take a look at questions where we're not given it within factored, where we're not given our quadratic in factored form here. So here we're given it in standard form, and let's take a look. We know how to factor because we've been working on that lately. We'll use our man method. So we multiply to positive 10, we're adding to positive 7. Multiplying to positive 10, I have 1 and 10, I have 2 and 5, and then I have my negative versions of that, so negative 1, negative 10, negative 2, negative 5. 3 and 4 don't work, they're not factors here. And I can see right away, 1 plus 10 is 11, 2 plus 5 is 7. That's what I'm looking for here. So my numbers are 2 and 5. So I can factor it. Oops, let's write that y a little neater. I can factor this as x plus 2, x minus, sorry, my apologies, x plus 5. And from here, I find my s equals negative 2, my t equals negative 5. So therefore, my zeros are negative 2 and negative 5. We will perform the same strategy here for example 2b. In order to factor, we'll use our man method. We're multiplying to 18, adding to negative 9. Be careful there with the negative 9. And if we multiply to 18, we have 1 and 18, 2 and 9, 3 doesn't work, 4 doesn't work. Oops, my apologies. 3 does work here. 3 and 6. 4 doesn't work. 5 doesn't work. And then I see the number 6 here, so I know that I'm done. So I can go into my negatives. Negative 1, negative 18, negative 2, negative 9, and negative 3, negative 6. We'll sum them up. 1 plus 18 is 19, 2 plus 9 is 11, 3 plus 6 is 9, negative 1 plus negative 18 is negative 19, negative 2 plus negative 9 is negative 11, and negative 3 minus, or plus negative 6 is negative 9. And that final one here, it's a good thing we got them all. Our final one here are the numbers we're looking for. So numbers are So my numbers that we're working with here are negative 3 and negative 6. We can factor that. Y equals x minus 3, x minus 6. And from here, my s equals positive 3, my t equals positive 6. My zeros are 3 and 6. There's my final answer. And finally, we're going to look at something a little more challenging yet. This is going to be the most confusing part about the topic today, so it might take a little bit of work. Follow this carefully. Make sure you're following it step by step, so that you could perform what I'm about to do here. So our goal is to find the coordinates of the vertex. Now, our first step is going to be to find our zeros right away. So my zeros, let's work as we were before. T equals positive 5, S equals positive 1. So my zeros are 5 and 1. So that means right away, I know I'll be sketching this quadratic, that means right away that I know I have a point at 5, 0, and at 1, 0. So those are the two roots of my quadratic. Those are the two places where my quadratic crosses the x-axis. Now I'm going to take a look and try and find one more point. What we're looking for here will be the vertex. Now, one thing we have noticed about quadratic functions is, they're shaped like this or they're shaped like that. But either way, there's some symmetry about them at their middle, which also goes through either their minimum or maximum. It goes through their vertex here. So we'll take a look and we'll try and use that symmetry in order to find the x-coordinate of the vertex, and then we'll find out what the y-coordinate is. So the our vertex, which is where the symmetry is going to be, must be halfway between our two roots. So if we take 5 and 1, if I'm trying to find the midpoint between 5 and 1, then what I do is I do 5 plus 1 divided by 2. I add them together, and then I divide by 2. I'll always divide by 2, because that's how you take a midpoint. And that's 5 plus 1 is 6 divided by 2, and that equals 3. And that makes sense. If I count it out here, that's 1, 2, 3. That's about where I drew in my midpoint anyways. So if they're midpoint here, I'll write it in as an x just so we're not confused, because that's not, because our quadratic won't be through this point, but we will still be able to use that point in order to find where our vertex is. So our vertex, we know we'll have the x-coordinate of 3. So our vertex is looking something like 3 and then y, whatever y is. So we're going to try and find y now. Well, one strategy that we can use here, really the strategy that we'll want to use, is we'll take this x equals 3, and we're going to substitute x equals 3 into the initial equation, which was y equals x minus 1, x minus 5. So if we substitute x equals 3 into here, then I have 3 minus 1, 3 minus 5, and I'm just performing some BEDMAS here, so 3 minus 1 is 2, 3 minus 5 is negative 2, and so my y-coordinate equals negative 4. So my vertex is 3, negative 4. I'm going to count that out. So I already counted my 3, that's where my x is, and then I'm going down 4, 1, 2, 3, 4. So here's my vertex. With these 3 points, that's all I need. I can use these 3 points to draw in a quadratic. And you know what? Just to make it a little more legible here, I'm going to draw mine in red. A quadratic shaped like this. Now, key parts of a quadratic when we're drawing it, we want our curve. First of all, it's not a line, it's a curve, so it's rounded here at the bottom. We want our curve to go beyond the last points that we drew. So we drew these points, we're still drawing our curve up and up, and we've drawn it all the way to the top of our axis here, and at the very top, just like I did here, we have our arrows. We have our arrows at the tips to show that the quadratic will go on. Let's see here. You'll see me try this same strategy one more time here with a bit of a different quadratic, and we'll see how that goes. Hopefully you're able to perform these steps on your own so that you'd be able to draw a quadratic just from getting an equation either in factored form or even in standard form, and being able to change it into factored form on your own. So let's see here, right from the get-go, I can see that t equals negative 4. I can see that s equals 2. I know there's a negative sign here. We're just going to, we don't consider that when we're looking at our s and t, when we're looking at our zeros here. So my zeros are 2 and negative 4. And so the midpoint of, and this is the right notation that I should have used last time, so the midpoint of 5 and 1. So what we calculated before equals this. This time the midpoint of 2, negative 4 equals 2 plus negative 4, write that in brackets, divided by 2. Well, 2 plus negative 4, that's just negative 2 divided by 2 equals negative 1. So that here, again, is the x-coordinate of our vertex. Now let's try finding the y-coordinate by substituting x equals negative 1 into y equals negative x plus 2 x minus 4. So I keep my negative here, and I'm just plugging it in. Negative 1 plus 2, negative 1 minus 4. All right, so still keep my negative here. And negative 1 plus 2, that's positive 1. Negative 1 minus 4, that's negative 5. So I'm left with a negative. I'm left with a negative times 1 times negative 5. So if I do that in 2 steps here, that's negative, oops, I have to go back to blue here. That's negative 1 times negative 5, and I know a negative times a negative is a positive, so I'm left with 5. So my vertex, therefore my vertex, is at negative 1, which I'm getting from here, negative 1, 5. So if I'm plotting that, I go negative 1, 5. My vertex is here. My 2 zeros are at negative 4 and positive 2. And this looks about right. I can see right away my vertex is about halfway in between my 2 zeros. So I can graph my quadratic right here. Note I'm going beyond my points. I'm drawing a rounded curve, and I have arrows at the end. So this is how we're going to do it. You can see quickly that we're being able to draw a lot of information just from being given one equation of a quadratic here. Now you'll note this quadratic here on the right side, it opens down. This quadratic here on the left side, it opens up. Well, that lines up with our previous the previous things that we know, which is if there's a negative sign at the beginning, it opens down. If there's not, it opens up. So there you go. You should be able to solve all of the problems on the homework today. That's your only work this afternoon. The rest of the afternoon will just be used towards catching up on past homeworks. Thank you.